Algebra 1. This is our last new lesson of the school year. This is lesson 11.8, Rational Equations. So 11.8, Rational Equations. And a rational equation is an equation that has one or more rational expressions in it. So a rational expression, again, is a fraction where the variable is on the bottom. So here we're dealing with equations that have at least one fraction with a variable in the bottom, would be a rational equation. Okay? And really, there's just one main thing that you need to do for solving these, but sometimes there's like a simplified version of the one main thing that you need to do. So, well, we could say this: if the equation is a proportion. So what's a proportion? That's an equation where it's fraction equals fraction. So you can set it up as one fraction equals a different fraction. So if it's that kind, then what you can do is cross multiply, then solve. Then solve and check for extraneous solutions. So in this context, what's an extraneous solution? It would be a solution that makes one of the original denominators zero. Okay, so you got to make sure that if you get a solution like x equals 3, that if you plug 3 into the original equation, it does not give you a denominator of 0. Okay? All right, so let's do an example of one like this. That is a proportion. You can rearrange it as fraction equals fraction, so you can do the cross multiply and solve. And we can look at what cross multiply looks like. It should be something that you've seen before, but just to make sure. So one like that, we can do something like this. I'm going to originally set it up like this. Let's do 2 over x plus 1 minus 4 over x equals 0. Okay. So note we do not have fraction equals fraction, but we do have fraction plus or minus fraction equals 0. So we could add 4 over x to both sides, plus 4 over x, add 4 over x. And what does that give us now? That gives us 2 over x plus 1 equals 4 over x. Notice now we have a proportion. We have a fraction equals a different fraction, or it could even be the same fraction, in which case, well, we won't get into that. Okay. So we do have fraction equals fraction. So how we can solve this is to cross multiply. Now, more fully what's going on is if I multiply this right-hand side by x, okay? Now if I multiply one side of the equation by x, what do I have to do? I have to multiply the other side of the equation by x, okay? But when I multiply by x, multiplication goes on top, right? So this x is on top. So what does that mean? That means that this x cancels with this x. Okay. But then I still have this x plus 1 in the denominator on my left-hand side. So I would want to multiply both sides also by an x plus 1. Well, when I do that, notice on my left-hand side, I now have an x plus 1 on top and an x plus 1 on the bottom, so those cancel. So what am I left with? I'm left with the numerator on the left times x, which was the original denominator on the right. Okay, so numerator on the left times the denominator on the right. And then I'm also left with the numerator on the right, 4, times the original denominator on the left. So I'm showing the x over here on the left times this, but the cross multiply is to say we'll do 2 times x equals 4 times x plus 1. And so if you wanted to, you could go straight to writing it like that. You could write it like 2, I'll go blue here. You could write it as 2 times x equals 4 times x plus 1. Numerator on the left times the denominator on the right equals numerator on the right times the denominator on the left. That'd be the cross multiply. But what's going on is you are multiplying both sides by each denominator. And so when you multiply both sides by the denominator on the right, the x on top cancels with the x on bottom, leaving you with just multiplying x on the left. And when you multiply both sides by the denominator on the right, that x plus 1 cancels with that x plus 1, and you're left with just 4 times the denominator that was originally on the left. Okay, so now we can go ahead and solve. So what do we get here? We get 2x equals, we need to distribute here, 4 times x is 4x plus 4 times 1, so plus 4. Okay, well, let's see what we get. So I need to subtract 2x from both sides, minus 2x minus 2x. And so what does that give me? That gives me 0 equals 2x plus 4. So now let's subtract 4 from both sides, minus 4 minus 4. So that gives me negative 4 equals 2x. Divide both sides by 2. And what do I get? I get x equals negative 1/2. All right, so let's see what we got. So we have to make sure that we don't get any, whatchamacallit, any extraneous solutions. That we don't get any denominators equal to 0. So if I plug negative 1/2 into, let's check for extraneous solutions. Again, this extraneous solutions. So I just have to make sure that each denominator doesn't become 0. So this is going to be a negative 1/2 plus 1. Well, that's not going to give me a denominator of 0. And then my other rational term here is just an x on the bottom. So that's the negative 1/2. So that's not going to give me a denominator of 0 equal or either. What am I going to get here? Negative 1/2 plus 1 is going to be a positive 1/2. Something doesn't look right here. Oh, that's what's off. Okay, hold on a second. If you noticed it, great for you. My bad. Negative 4 divided by 2 is negative 2. So my solution here is negative 2. So I'm not plugging in a negative 1/2, I'm plugging in a negative 2. So this denominator is a negative 2. And if we just do a whole check here, assuming if we'd started with it like this chunk here, rather than the way that I wrote the beginning, but we could write it like the way, the way I wrote the beginning. So this would be a minus. Does that equal 0? Well, let's see. So this becomes 2 over negative 1 minus, which is, okay, well, I'll get there. 4 over negative 2, that's negative 2 minus a negative 2. Does that equal 0? Well, this is negative 2 minus negative 2 is plus 2, and yeah, that's going to equal 0. All right, so it checks. it checks out. That would be a full checking of your answer. The checking for extraneous solutions, you just have to make sure that neither one of the denominators equals 0. All right, so that's one that you can do just with the cross multiplying. Let's do this one next, because sometimes you won't be able to. So let's see. If you cannot cross multiply because greater than 2 terms, so you can't just write it as fraction equals fraction because you have more than just the 2 fractions going on. Maybe it's 3 fractions, maybe it's 2 fractions and some other value. Then what we do is multiply each term by the LCD, lowest common denominator, or least common denominator. Then solve and check for extraneous solutions. So let's do one like that. So this could look like this: x plus 3 over x minus 6 over 5x equals 1 over x. So we have 3 terms going on. We have the first fraction, the second fraction, and the third fraction. All 3 terms are fractions. All 3 terms are even rational expressions here. But we cannot just cross multiply because you can only cross multiply when you have fraction equals fraction. So what we can do is we can multiply each side by the lowest common denominator. So what is the lowest common denominator here? In other words, what is the smallest thing that would have each one of these denominators as a factor? And I see, well, what does each denominator have in common? What do we have going on here? We have an x in each, but then we also have a 5. So the LCD here, LCD, is 5x. So 5x is the smallest thing that that will get rid of all of our denominators. If we multiply each term by 5x, we will end up getting rid of all of our denominators. Yeah. I'm trying to remember what lesson has finding LCDs in it too, if you want to go back and look at your notes for that, for double checking. I don't even remember we had a specific lesson in this course. I'm trying to remember. Should have looked that up beforehand. I didn't think of that as something that would come up. Let me see. I'm taking a quick look at the index of the textbook, and we'll see what we get. I, J, K, L, LCD. See, least common denominator. Okay, we go least common denominator. The biggest chunk of pages that it mentions is pages 708 to 710. 708 to 710. Oh, that's our adding rational expressions, huh? 705, 708. Yeah, see, they're assuming, yep, that the LCD is something that you have enough experience with at this point, that it's not a topic that is technically this course. Okay. Yeah, some of that is just a little bit of experience of just seeing, okay, well, let's see what is if I analyze my 3 denominators, What is the smallest thing that could have each of those denominators as a factor? Well, 5x can be written as 1 times 5x, but then 5x has an x in it, and 5x also has an x in it. So 5x will fit everything. I can't just say x because x doesn't have 5 in it. The LCD, let's just say you had something like, let's say you had denominators of 3x and another denominator of x squared. The LCD there would be 3x squared because this has a 3. That's the biggest number you have going on. So my LCD needs to have a 3 in it, but then this just has an x, but I have an x squared going on in here. So if I have an LCD of 3x squared, this has as factors of it all of the other everything that is in all of my denominators. 3x squared you can factor out a 3x. 3x squared you can also factor out an x squared. In this case, 5x you can factor out an x, it'd be x times 5. 5x you can factor out a 5x, is 5x times 1. And then again, 5x you can factor out an x. Okay, so back to this problem. We need to multiply each term by the least, since that's the more common wording, least common denominator. So here's what we get. We get 5x times x plus 3 over x minus 5x times 6 over 5x equals 5x times 1 over x. And let's see what cancels. Okay. Well, this is an x being multiplied. Now, this x here cannot simplify, cannot cancel that x there because this x has addition happening to it. You can only cancel with an x on the bottom if you have on top x that is only experiencing multiplication. So this x here, this x here is only experiencing multiplication. So it can cancel with the x on the bottom. Wrong color, sorry. Struggle is real this class. So that x cancels with that x. This 5x cancels with that 5x. And this x cancels with that x. So what do we get? We get 5 times x plus 3 minus x times 6 equals 5 times 1. Yay, all of our denominators are gone. So let's see what we have. This becomes 5x plus 15 minus 6x equals 5. All right, so on my left-hand side, I get negative x. And if I subtract 15 from both sides, 5 minus 15, 5x is negative 10. I do something, hold on a second. 6 minus 6 equals 1. Okay. 5x plus 15 minus 6x equals 5. Something doesn't feel right here. If I subtract 15 from both sides, it's going to give me negative x equals, x plus 3 over x, good, minus 6 over 5x, good, equals 1 over x, good. So I multiplied each term by 5x, good. X's cancel, I'm left with 5x plus 15, all right, minus the 5x's cancel. Oh, minus 6, that's why. This x is canceled. I saw that as just canceling the 5. The whole 5x got canceled. So that x right here should not be there. So this is just minus 6. All right, that is much better. So I'm left with on the left-hand side 5x. And here I have my 5 still, and I need to add 6, and I need to subtract 15. So what do I get? I get 5x equals 5 plus 6 is 11, minus 15 is negative 4, so x is negative 4/5. Okay, and that will not give me a 0 for any of my denominators. So good, so that's my solution. All right, let's do one or two more sample problems, and that will do it for this lesson. So that was that one. I also wanted to do, yeah, let's do one more like this. Yeah, then one that is a little bit more ugly. No, I don't need to do one like that. Okay, let's do one more that's kind of like this. So this one I want to do 2 over 3x equals 2 over 15 plus 2 over 5x. So what value of x would make that true? That's a 5, just to make sure it's clear. All right, so let's find the LCD. LCD, what's the biggest thing that 3, 15, and 5 go into? Well, 3 and 5 are both factors of 15. So 15 will work for the number part, and then I need an x in order for each term to also fit into it. Okay, so my LCD is 15x, so I want to multiply each term by 15x. So we're going to go 15x times 2 over 3x equals 15x times 2/15 plus 15x times 2 over 5x. Okay, let's see what happens. Well, so my 15x over 3x simplifies just to 5. My 15x over 15 simplifies just to x, and my 15x over 5x simplifies to 3. So what am I left with here? I'm left with 5 times 2, that's 10, equals 2x plus 6. So then if I subtract 6 from both sides, I get 4 equals 2x. Divide both sides by 2, and I get 2 equals x. That is theoretically my solution. Hold on a second. Okay, yep. That is theoretically my solution. I just got to make sure that I don't have any denominators or 0. Well, 3 times 2 would be 6. 15, that just stays. 3 times 2 is 10. All right, good. And if we did a check here, what would we get? We would get 2 over 6 equals 2 over 15 plus 2 over 10, right? So if we wanted to add these, we need a common denominator, 2 over 15 and 2 over 10 to get a common denominator, 1530. So both 10 and 15 go into 30. So I can say 2/15. Well, does that equal? So 2, 6. So I need to multiply these by 2, 2 over 2. This one by 2 over 2 to get it in terms of 30ths. So that would be 4 30ths. And then this one I need to multiply by 3 over 3 to get in terms of 30ths. So that would be 6 30ths. So what is that? 10 30ths. 10 30ths, which is 2 6. You know, if you divide everything by 5, you get 2 6, which is 1/3, because 2 6 is also 1/3. Cool. All right, and one more example. Something a little uglier like this. X plus 4 over x minus 2. X plus 4 over x minus 2 plus 6 over x minus 2 equals 1 over x plus 3. All right, so let's find our LCD, least common denominator. Well, for this one, the biggest thing that you can factor out an x minus 2 and an x plus 3 is just x minus 2 times x plus 3. When you have two different binomials going on like that, that's the best that you can do. You can just multiply each term by those two different terms. So let's see what we get. So we have an x minus 2 times x plus 3 times x plus 4 over x minus 2 plus x minus 2 times x plus 3 times 6 over x minus 2 equals x minus 2 times x plus 3 times 1 over x plus 3. Now let's look at what cancels. My x minus 2 over x minus 2 cancels. My x minus 2 over x minus 2 cancels. My x plus 3 over x plus 3 cancels. So what am I left with? I'm left with x plus 3 times x plus 4 plus x plus 3 times 6 equals x minus 2 times 1. Okay, let's work towards solving this. So we're going to have to multiply everything out and simplify. We're going to end up with a quadratic equation to solve. So we might be able to solve it by factoring. We might end up deciding to use a quadratic equation. We'll see. So when I FOIL this, x times x is x squared plus 4x plus 3x. That gives me plus 7x plus 12 plus x times 6 is 6x plus 3 times 6 is 18 equals x minus 2. All right, what simplifies? I'm going to want to end up with an equals 0. I only have just the x squared term. Then I have 7x plus 6x. That's 13x, but I need to subtract an x, so 12x, so plus 12x. And then what do I have? I have 12 plus 18. That's 30. I need to add 2 more. That's 32 equals 0. Okay, let's see if it can factor. So I have a 1x squared. So I can take my 32 and look for two numbers that multiply to be 32 and add to be 12. 32 is, let's see, 8, 16, 8 times 4, right? 8 times 4, that will work. 8 times 4, because 8 times 4 is 32, 8 plus 4 is 12. So this can factor straight to be x plus 8 times x plus 4 equals 0. So x plus 8 equals 0, or x plus 4 equals 0. So then x equals negative 8, or x equals negative 4. I really shouldn't quite be boxing these yet because I haven't checked for extraneous solutions. So my denominators were, what? X minus 2 and x plus 3. So I had an x minus 2, another plus something over x minus 2, and then equals something over x plus 3. And if I plug negative 8 in, that won't give me any zeros if I plug negative 4 in. So I could say no zeros in those denominators. So therefore, 3 dots like that in a triangle means therefore no extraneous solutions. So both of those solutions work. All right. You maybe will get a couple that are like this on the homework. This is about as extravagant as they get at this level. Mostly, though, you'll get a couple that are maybe like this, some that are maybe like that, and then even more, if I scroll all the way up to the first example we did, that are either like this or it's already set up like 2 over x plus 1 equals 4 over x, and you can just jump straight into cross multiply and then solve from there. So I hope that makes sense. Let me know if you have questions, and I'll see you next time. Well, next time is final exam review. Bada bing.